Hello all, welcome to Excel Academy. So today we are back with DSP concept. As I told you, we are going to study with respect to properties of DFT, that is symmetry property. So in the last two, that is what I can say, the properties, that is your linearity and periodicity, you did not find any problem. So there are problems with respect to properties also, and with respect to linearity and periodicity you don't have any problem, and with respect to symmetry you have problem. Fine, we are going to do that. And circular convolution also, you have problems with respect to circular convolution, but that is already done. Fine, yes. So now let me consider the symmetry. Let me consider the symmetry property, and according to my symmetry property, so let us consider the sequence. Just a minute. So sorry. Let us consider the sequence, that is a x of n sequence is what? It's a complex value. So it is that we are making an assumption that a x of n is a complex value. We are not, it has not been told in any of the, what I can say, the books or any one who found out. Scientists haven't told that this x of n is a complex value. But here, so we are, that it is that we here are considering that x of n is a complex sequence. Fine, complex valued, and we are going to write the test. So just a minute. Okay, and complex valued, and we write it as, so students try to follow this without fail, because these things are really important. And as I already told you that you're supposed to, what I can say, you're supposed to follow the order, right? The order of the video. So you can see a DSP playlist. It is public playlist. You can just check it out as DSP. I just capital DSP itself. Please do check it out, and please to watch all the videos there, because I'm going to work it out with respect to VT examinations only. Because as I told you in the intro video, so that intro video I've left it in some other channel. Okay, so here you can see that, and I was always, I'm sorry, I was always telling you that, knowledge gaining is something different, your examination is something different. So it is like your what I can say, it is like at the end you're going to write your examinations. Fine, at the end you're going to write the examinations, and for your examinations you're supposed to work it out. Knowledge gaining is something that you have to keep it aside. You will gain knowledge while studying, I'm not telling that, but at the end you're going to write your examination. So if you try to learn blankly the things, and if you're going to attend your examinations, then it is really become worst. So try to understand how it comes for exam, what are the topics that come for exam, what the type of questions that come for exam, how I have to work for this particular subject. If you know these four things, you can easily crack your examination without fail. And first learn these four things and then go to knowledge gaining. So you can gain knowledge at any point of time, but while you are writing a university examination, whatever the question is given, according to that you are going to answer, and that particular thing matters. That is why try to understand these four things before going to university examinations, and crack your exam in a easy manner. Fine, I am telling all those things. Fine, whatever I have did till now, I told you that 4-point DFT is really important. I also showed you the question paper wherein you did not even see any 8-point DFT question. Fine, did you see? No, you did not see. So that is why you have to see how the question is coming. A 4-point DFT is always an important question. From all the 4 question papers, you did not miss any question from 4-point DFT. So try to solve 4-point DFT questions without fail. And I also told you to solve the theorems without fail. The two circular convolution has been asked many a time. And I also told you to solve question with respect to circular convolution using concentric circle method and DFT IDFT method. matrix method and this particular which method, yeah, formula method, all those things I told you. So whatever I told you with respect to DSP, you're going to follow the same without fail. If you follow the same, you'll easily crack your exam. That is what you need to understand first. Because if you're not giving any examination, if you're just learning for the sake of knowledge, it is fine. You can learn in any manner. That is not a matter to you all. But when you're trying to write a university examination, so please do go according to the university examinations only. Please do have the question paper with you without fail, along with one textbook, one reference book which is containing more and more problem. Because the textbook that has been told to you for DSP, it doesn't have Procalis and Monacalis. That textbook they've told, some name I don't remember, but this name only. Yeah, so that textbook doesn't contain much of problems, so try to have another reference book. I told you Ganesh Rao or technical publications to have along with you. And you should have a notebook for practice, or if you have this kind of whiteboard what I'm showcasing you now, it's fine and good, better. Along with that, you can have your what I can say, the syllabus copy and your question paper. Say syllabus copy also makes your sense, because when you see the syllabus copy and you get to know what is there for you and what not is there for you. So see that and practice. Study what is there for you. What not is there for you can learn it later, but what is there for you, study. Because if you study both, which is there for you, not there for your time is going to waste. So that is why try to study what is there for you. Try to study within the syllabus. And then you have to have a question paper. So question paper, you can see how the question comes and which topic have more and more importance, weightage, right? This technique you should work for problematic subject without fail, because many will be having what I can say, the misconception with respect to problematic subject, like it is difficult, we can't do that. Somewhat it is quite difficult, and the questions doesn't come in an expected manner. All the things you people will be having, right? So to eliminate that, try to work it on this basis for problematic subject. For theory subject, it is like you can manage. For theory subjects also, you can use this technique, but for theory subjects, what is supposed to do is you have to jot out all the questions that has been present in the question papers, last year question papers, and all those things you try to jot it out in one paper, and try to study all those questions without fail, and then go to the remaining questions which is not asked, and you can practice. But for a problematic subject, it is not like that. When you see the question paper, when you see one question, you're supposed to look at different types of questions on the same basis. Fine, if you see one problematic question in the question paper, you need to practice that question. Go take the textbook, see that these kinds of question have you have any in the textbook. Fine, those things you have to do. But for theory, it is not. If you just practice one question, it is enough. You can't go to another question searching for a textbook. Fine, that is why. Okay, so for theory, utmost try to have your question paper, list out all the questions that have come in the question papers previous years, and try to practice all those questions without fail, and try to mark it out from which concept it have come, that particular question. And please do mark it out in the syllabus also. This concept is over. From this concept, you got a question from the question paper. Fine, and then you'll get to know the remaining. So remaining concept, if you tick mark all the some of the concepts in the syllabus copy itself, then you remain with some topics which have not tick marked or unticked. So those concepts you try to see how the question comes and just practice. So theory and for theory, this kind of procedure we need to follow to easily pass theory subjects. And for problem subjects, what I told now is that see a question, practice that, and then check with the same type of questions, different types of questions on the same basis in the textbook, and start doing it. Fine, that is what is supposed to do. I will tell always all these things, because many people get confused how to start studying. They don't have a proper idea on how to start studying. They just think like whatever they do in the class today, study, and they'll just study and they'll just by heart and go right in the exam. No, there are some tips and tricks to start your a particular subject, whether it is theory or problem, and is that exam in a good manner. So these are those, and try to practice in that manner only without fail, so that you can ease your exam. Fine, especially problematic subject, you should have your textbook, one textbook, that is we do prefer textbook. You can check that with respect to your syllabus, and you can see that if it doesn't have any problems, that is we do prefer textbook is not having much of problems for you, Try to get a good reference book like Ganesha was there for you, or you can say that Bakshi with respect to control, or this technical publication with respect to DSP. You can check it out and you can try to so you can have it. Along with that, you need to have a syllabus and your question papers, and you should make use of those properly. Fine, first you need to take the syllabus copy, check with the very first topic, check with the question paper whether it has come in the examination or not. If it has come in the examination, check what type of question have come from the topic. Try to search the same kind of question what is being given in the question paper with different numericals, right? The question will be same but some numericals will be different, or some part of the thing is different. So that, like that, you're going to check it in the textbook and you're going to work it out. This is what you're supposed to do. If you don't do this, then you can't even crack your exams. That is why that is what you need to do. Fine. And this is what for your good I told you. And now let me come back to this. So you can see here, if you consider this x of n as a complex valued, and we write it as, see what x of n is equal to xr of n plus j xi of n. I guess you will be having some doubt with respect to what is r and what is I. Fine. What is r and what is I? So here r and I is what? So here r and I is real and imaginary. Fine. We are considering that this is a complex valued. So what is complex valued? Complex valued is having one real part and one imaginary part. Fine. Now let me consider this is my x of n. So let me consider that the DFT of this x of n, that is this. See here, the DFT of this x of n is also complex valued, and I am going to write the same, that is DFT of x of n, which I call it as x of k in the same manner. Fine. Instead of x of n, I replace it as x of k, wherein here it will be xr of k plus jxi of k. Fine. I'll write that. So I'll write it as let us consider x of k, and directly write x of k is DFT of x of n. Fine. Is a complex valued wherein, just a minute. So see here students, there is no what I can say the statement directly. We are going with respect to the proof. Fine. Yes. So directly we are going to come with respect to the proof. No need of writing your what I can say the statement and the proof. They start directly doing like this. Fine. Okay. So complex value, and we can write it as x of k is equal to what? My xr of k plus jxi of k. Fine. Yes. So now this and this is over. So now what I have to do is I need to use my formula. So I need to substitute substitute x of n in the formula. There the formula is n minus 1 to n is equal to 0, x of n into omega n kn. Fine. There I am going to substitute this x of n. So let me write the formula of DFT formula. So that is the DFT formula has been given by x of k is equal to, that is summation of n minus 1 to n is equal to 0, that is x of n into e to the power of minus j 2 pi by n kn. So you have to write this only students, because omega n kn I am going to take it like this. Fine. Omega n kn I have to take it like this in the next step. Instead of that I am going to directly write this. Fine. Okay. So now next thing what I am supposed to do is that I have to take n minus 1 to n is equal to 0. What I can say, h of n I need to substitute with this. Fine. This x of n has to be substituted with this. So I can write it as xr of n plus jxi of n into e to the power of minus j 2 pi by n into kn. Fine. Yes. So now what I can say, if I have to take this e to the power of minus j 2 pi by n into kn, I can take it in terms of what? I can take it in terms of, that is this one. Which one? Your cos and sine, right? It is cos, what I can say, 2 pi kn by n minus j sine 2 pi kn by n. I have to write. Fine. So now let me do that. So here I need to put a bracket because this is for both. Fine. So now just a minute, student. So sorry for the distraction. Okay. So now I'll try to substitute that. So if I try to substitute that, so I can get it as what? I can get it as what? I can say my which is equal to summation of n minus 1 to n is equal to 0. So that is what I can say my this one. Which one? That is your x r of n plus j x I of n. So what I can say into, just a minute, student. So sorry. Yeah. Into, it is into this one. So it is into what I can say my cos. I'll write it like this: cos 2 pi kn by n minus j sine fine. Yes. So now I have to multiply this. So first I have to multiply this particular for both and this particular for both. Fine. If I do that process, I am going to get my result. So sorry for the distraction that happened in between. I had to check with respect to this multiplication procedure. So see here, you can see that this xr of n gets multiplied to this cos 2 pi kn by n, which you are going to get is that this resultant. Fine. Now what's that going to happen is, here you're going to take one single thing, that is xr of n, and you're going to multiply with this as well as this, and then you're going to take this jxi of n and you're going to multiply with this as well as this. Fine. That is what we will do, and we are going to separate it out here. Fine. Here it has been separated. How? I'll tell you that. So see here, you can see that this xr of n gets multiplied to cos 2 pi kn by n. That is resulting in xr of n into cos 2 pi kn by n. Yes. And then what is supposed to do? You are going to multiply this xr of n to this particular, that is minus j sine 2 pi kn by n. So you are going to get it as what? You are going to get it as this xr of n minus xr of n into minus j sine 2 pi kn by n. You are going to get it as, fine. Keep that like that only. Fine. Then if you take this jxi of n into cos 2 pi kn by n, you are going to get it as, that is jxi of n. This jxi of n into this cos 2 pi kn by n, like this only. Here you get j, that's all. And if you try to multiply this with this, what happens is this j and this j will get eliminated. So when it gets eliminated, so this minus j and this plus j always will tend you to 0. What? This minus j over here and this plus j over here is always tending you to 0. Fine. So that is why you are going to get a resultant as this xi of n into what I can say, that is sine 2 pi kn by n. Fine. Yes. So now here, so what is supposed to do is that here we have taken all the j terms together. Which are the j terms? So the j term says this xr of n into minus j sine 2 pi kn by n. That one you have taken. See, xr of n into sine 2 pi kn by n, and this minus j is outside. Why minus j is outside? Because if you multiply minus j to this, you get it as xr of n into minus j sine 2 pi kn by n. And but here if you multiply minus j to this particular, so minus of minus is becoming me plus. So I get it as what? That is plus x, so what I can say, I of n, right? Plus xi of n into cos 2 pi kn by n, that is this, plus jxi of n into cos 2 pi kn by n. That is what we are getting. And here it is what? That is this xr of n into cos 2 pi kn by n. And what I can say, this multiplied by this resultant is xi of n into sine 2 pi kn by n, right? We are taking all the j terminology part is on this side, and what I can say, my without j it is this side. Fine, that is what we have done it. And this particular thing is what we have written the resultant in IDFT form. So in IDFT form we are going to get the resultant like this. In IDFT form you have 1 by n, that one you have to remember without fail. Fine, yes. And here it is k is equal to 0 to n minus 1. Just a minute, it's k is equal to 0 to n minus 1. Okay, a minute student, so sorry. Where did I keep it? Yeah, here. Here it is k is equal to 0 and here it is k is equal to 0. So it is k is equal to 0 to n minus 1 and it is all this. Fine, I guess you understood how this is going to work it out. Fine. So now what I am supposed to do is that here it is subtraction. So sorry for the distraction that's happening over here. Fine. So this is what is for this particular, that is symmetry property thing. And then now we are going to, what I can say, come to symmetry property of the real sequence, that is x of n. So the symmetry property of real sequence x of n, that is the real valued x of n, is same. What? It is same like that of, what I can say, the which one, that is your periodicity property that we did. Fine, in the case of periodicity property we were just substituting, what I can say, which one we were substituting, that is n plus k or k plus n we substituted, but there here we are going to substitute, what I can say, n minus k in the place of k plus n. There we substituted k plus n in the place of, what I can say, that is n. So you can even see that particular thing, we substituted replacing k by k plus n. But here what we are doing is we are replacing, what I can say, that is your this one, which one, that is what I can say, n by k by n minus k. That's all you're supposed to do. Okay, so I guess you can understand that easily. The same process that goes on with respect to periodicity only, but in the place of k, I'm going to substitute n minus k. If you try to substitute n minus k, I'm going to showcase it to you in the book itself. So it's quite easy. Okay, so you're going to substitute n minus k. That's the values of n minus k. You're going to substitute. And if you substitute in the place of k, that is n minus k. Where you have to substitute? That is here. There is a k. No, this k. Kn. This k. See, I'll round it off in green. For this k, you are going to substitute n minus k. So if you substitute n minus k, that is for this k, in the sense you have to take here, that is omega n kn. So what I can say, your formula will be here omega n kn. I write the formula here itself. So it is omega n kn, and for this k, you are going to substitute n minus k. So if you substitute n minus k, what's that going to happen is that you get omega n into minus kn, and you get 2 here. That is one is omega n into nn, and omega n into minus k you are going to get. So omega n into nn, you know that it is 1. I have already discussed with respect to periodicity property. Fine, that one you have to do. And then omega into the power of minus kn. So result with x of n into omega into the power of minus kn, wherein that is you get it as minus x of k. Fine, that I am going to showcase it to you in the textbook itself. It is quite easy, and this is what is for today's lecture series. So to understand this much properly, if you try to understand this much properly, you can just try to solve those things without fail. And this is what as I was about to tell you. And please do try to like, share and subscribe, and what I can say, share it to many other people who is in need of this particular. And thank you. So coming back to this video, you can see here that I told you it is the same thing. So but this property for real valued x of n, that is symmetry property for real valued x of n, is telling you that this x of n minus k is equal to x star of k, that is equal to x of minus k. Fine. So for that we need to follow the same periodicity procedure. So you can see here, so this formula I've used in periodicity, and we also substituted in the place of k, we substituted k plus n, but here it is n minus k. Fine, here it is n minus k, but there it is k plus n. So if you substitute n minus k, so we substituted n minus k over here, we just multiplied that, wherein we got omega into the power of nn, wherein it was 1, right? We did the same in periodicity. This is omega n to the power of minus kn. There we got, I guess, plus kn. So here you get the resultant as this omega n to the power of n is 1. So you get the resultant as this, that is x of n into omega n to the power of minus kn, wherein you get x of minus k. Fine. So that is x star of k. How you get? X star of a, how we get is like this. That is, this formula is for x star of k. That's x of minus k. Fine. So we proved it. So you can even check with respect to periodicity over here. So here in the case of periodicity, see, you can see this same formula. In the place of k, what we did, we substituted k plus n. There it was n minus k. Fine. So here we substituted k plus n. Here we got plus kn. There we got minus kn. This nn was equal to what I can say 1. Right? Have we written the same there? Yes. But instead of k plus n, we are substituting n minus k. That's all. And now if I come to the real and even sequence. So real and even sequence, that is, it is x of n is equal to x of n minus n. That is symmetry property with respect to real and even sequence. Here x of n will be x of n minus n. So that is, your x of k formula will be this formula. That is x of summation of n is equal to 0 to n minus 1. X of n into cos 2 pi kn by n. Fine. Yes. So here is given some proof, that is above equation is obtained from equation 2.121. Since x1 of n is equal to 0 and x of k is equal to xr of k plus xi of into xi of k, this one. And here is telling that since x1 of n is equal to 0 and sine function is an odd function, this can be verified by taking an example. So here he is taking this particular example, okay, and he has told something. So this is not that much required, but you need to know this particular thing. If your symmetry is a real and even sequence, your x of n is equal to x of n minus n, and your formula is this. Fine. Now for a real and odd sequence, you have to understand that x of n is equal to minus x of n minus n, wherein it is n is equal to 0 to n minus 1. That is here minus j into n is equal to 0 to n minus 1. That is x of n into sine 2 pi kn by n. This is what you get. Fine. Have to remember for real and even sequence this particular thing. For real and odd sequence, this particular thing. This much you have to remember. Fine. Yes. And then for purely imaginary sequence, so it is, here it is sine, and for even it is cos, and here it is for purely imaginary sequence, it is x of n is equal to j xi of n, wherein here xr of k and xi of k. That is for purely imaginary sequence is telling that this is half imaginary. This is real and odd sequence. This is not purely imaginary sequence. Here it is a purely imaginary sequence. So for that you are supposed to write here xr of k as well as xi of k. So xr of k is now becoming equal to n is equal to 0 to n minus 1. That's x1 of n into sin 2 pi kn by n. This is xi of k is equal to n is equal to 0 to n minus 1 xi of n cos 2 pi kn by n. Yes, so that is why you are going to write this resultant. Fine, this much you have to remember. Make a column with respect to this real and even sequence, and make sure that your x of n is equal to x of n minus n. Real and odd sequence, x of n is equal to minus x of n minus n, and your x of n is equal to, that is j xi of n. Fine, and the resultant you have to practice. Here the resultant is the same, but here it is cos, here it is sine. In place of cos you are going to write it as sine, and here one minus j will come into existence, and here it is this particular. Fine. So this is what I was about to tell you, and please do understand things in a better manner so that it would be really helpful for you. There are some things which are not needed, so I'm directly telling you to learn this without fail. So this is what I was about to tell you, and thank you.